So by now you've either found that booklet or you haven't, and I've got some spare sheets here if you need it. This is the booklet I was talking about, Sam. So it's been a little while since we've looked at Surds, and you need to know that the test on Surds and indices will be at the end of next week. We're almost through the material for it, so there will be an opportunity for you to revise. And on Thursday, I'm going to give you an indices homework assignment. You've already been given a Surds assignment, so I need to get back to you. I have plenty of time to mark it too. It's all my fault that it's not back in your hands. You'll get that on Thursday, though, to do a bit of a revision for indices as well. Anyway, the story so far for Surds. So let's start off with this. I've talked about being able to group numbers in different ways based upon their properties. For example, we haven't talked about this before, but all the whole numbers, positive, negative, and zero, are called integers. That's a grouping of a specific set of numbers. Their property is that they're a whole number, no fraction part. Who can remember, it's okay if you can't, but is there anyone here who can remember what we classify a surd as? Okay, fair enough too. So if you remember, maybe you don't, obviously you don't, you can break all numbers into two categories, broad categories. You've got rational numbers and irrational numbers. Is this sparking a thought in your head? Surds belong to one of those groups. Here's a 50-50 for you with no penalty. Which one does surds belong to? Are they rational or irrational?
Irrational.
Yeah, good. Now that you remember the words, you've got it. Irrational. So remember, rational numbers, all integers, for example, are rational. So are numbers like 2/3 and 5/7, etc. They're rational. And then you've got your irrational set, the bulk of which are things like root 2, root 3, root 7, things that if you square root it, it's the square root of a not square number. You know, so root 9 is rational because root 9 is just 3, right? Root 4 over 16, no, that's a bad example. Root 4 over 9 is rational because root 4 over 9 is just 2/3. Okay, they're all rational, but root 7 is irrational. Root 2 is irrational. The cube root of 5 is irrational, etc. All of these are irrational numbers. And then you've got things like pi and that's probably the most common one, actually. I won't go any further because it'll be too confusing. Okay, all of these are irrational, and surds are a big group of these, which is why we're learning to deal with them. We're focusing mainly on square root surds. So the square root of 2, the square root of 3, the square root of 5, etc. And they are so common that we usually drop the square bit. So we just say root 2, root 3, root 5. Yes, yes, yes? If it was something other than a square root, I would actually have to say it when I explicitly say it. So the cube root of 5 is a surd. The fourth root of 19 is a surd. So cube root of 8 is not a surd because the cube root of 8 is 2 because 2 times 2 times 2 or 2 cubed equals 8. Okay, I'm doing all this verbally because it's stuff that we've covered before. I'm just trying to reorient your brain to what we were doing before. Anyone got any questions about that? Okay, just the usual from this class then. What's root 2 times root 3? How do we do it? We looked at operations and we looked at multiplication, addition, subtraction. We looked at a bit about division as well. So there's a nice simple one for you. Root 2 times root 3. Nice? Yeah. So when we multiply two square roots together, we just multiply the numbers out underneath the square root. So root 2 times root 3 is root 6. What is root 2 plus root 3? Sam?
I have forgotten how to do that, Richard. I'm sorry.
Not a problem at all. Who can help Sam out? Okay, you're all correct. You can't do anything with root 2 plus root 3. They are effectively different surds. They represent different values and therefore collecting them together does not make sense. Now, for the purpose of the video, I'm just saying I'm going off to the whiteboard. If I had 3 root 2 plus 7 root 2, I could add those together because they're the same surd, they're the same value. I would have 10 lots of root 2 and that'd be fine. Am I okay? Is everyone okay with that? Okay, so in a way, it's a bit like algebra. Not perfectly, but it's a bit like algebra. Because if they are like terms, in inverted commas, then you can add up the numbers before it, which are kind of like coefficients. 3 plus 7 is 10. Okay, and we keep the root 2 there. Where it comes, because they're numbers and not actually variables, we do have a little bit more flexibility. And again, for the video, I'm just doing it off to the side. So, for example, if I had root 8 plus 3 root 2, at the first step here, we would say, oh, we can't do anything with that because they're different square roots. However, what can we do with root 8? What do we call that? Okay, with root 8, so your answer was correct, but to uncover it, we can simplify root 8 by recognising that a square number goes into 8. What square number goes into 8? 4. So we can, in our heads, so this is like a thought bubble, don't have to do this on when you're writing, you can go, well, root 8 is root 4 times root 2, just like everyone was able to say that's root 6 up here. I'm just going backwards. And so that's 2 root 2. Root 4 is 2, so it's 2 root 2. So that equals 2 root 2 plus 3 root 2, which now equals 5 root 2. So there's a bit more to it with Surds addition that you wouldn't have in algebra, because sometimes you can simplify those surds so you do have like terms. Okay, that's all I wanted to say about that, but I wanted to check on that. Okay, with that in mind though, then, root 18 minus root 12, can they be subtracted or not?
Yeah. No, they can be simplified.
They can be simplified. So if they can be simplified, then maybe there's a chance we can subtract them. But if anyone said no straight up, the answer is not yet, probably, rather than no. I don't know yet. So you take root 18 and root 12, and if you can simplify them down to the same square root, then you'll be able to subtract them. So I'll give you just a minute to do that. Just got a bit of scrap bit of paper on the sheets that you've got. Just see if you can get there before me.
4, is it 4 root?
Don't call it out though, because that robs other people the chance to work it out for themselves. Just a minute. If you're completely lost, I'm going on in a minute, so it's okay. So just to go through that process again, we look at each square root in turn. We look at it and say, well, what are the factors of that number, and are any of them, apart from one, square numbers? If the answer is yes, we can simplify. If the answer is no, then it's as simple as it can get already. So I'm going to ask a few people questions here, just one at a time. Sam, I'm going to pick on you again because you were calling up the answer before as well, so I think you're on the right track for this one. I'm just going to ask you just a part of it. Root 18, what square number goes into root 18?
9.
Right? 9 goes into 18. So we can split root 18 into root 9 plus times root 2. So again, you would do this in your head, preferably. Root 18 equals root 9 times root 2, which is 3 root 2. Okay, so root 18 becomes 3 root 2. Yeah, root 12. What square, Sarah, what square number will go into 12? Say it again? 4. Yeah, 4 goes into 12, and 4 is a square number. So we can go root 12, whoops, nearly lost my pen there. Root 12 is, again, all in your head, root 4 times root 2, and the square root of 4 is 2. So we've got 2 root 2. Huh? Oh man, you're right. I didn't mean to. That's a stuff up by me. It was meant to be the same with square root number, but I've stuffed up. Oh well, it's okay. 2 root 3. Okay, having simplified, can we now subtract them? No, because they're different square roots. I love how a certain person, I won't mention their name, was nodding emphatically and then went straight to a shake of the head when I said no. 3 root 2 minus 2 root 3 cannot be simplified further because it's still not the same square root sign. Now, I didn't do that on purpose. I just stuck up in my head. I should have said root 18 minus root 8, shouldn't I? Something like that would have worked nicely. But I didn't. I stuffed up. So we can say for sure, now that we've simplified the surds, it cannot be subtracted any further. But if they were the same surd, then I could subtract. Any questions on that? No, you cannot ask why, you an idiot, Richard. Will?
I don't really understand it very well.
Okay, I'll come and help you one-on-one on that understanding. Thanks for that. Now I can come and sit down with you. If there's anyone else in the same boat as Will that it still doesn't make sense yet, make me sit down with you until you do get it. Okay? It's really important. Yeah.
Just a question.
Yes?
Because you can go from like root 2 times root 3 is root 6. When you simplify it, can you go like the other, like, because in these ones you can only simplify it as a square number in one of those factors. Can you not use the same technique if it's not a square number?
As in like root 6 is root 2 times root 3?
Yeah.
If you do, I'll do it on the whiteboard, so again it'll be lost on the video. But I think what you're ending up doing is not making it much better for yourself. So if I had, just stop me if you think I'm not answering a question. If I had root 18 minus root 6, and I said, well, root 18 is 3 root 2, for the reasons I said before, and root 6 is root 3 times root 2, I've still got a root here that won't, I can take out a common factor of square root 2, and that would leave me with 3 minus root 3. And that might be useful, but it doesn't feel any simpler than what we started off with. Yeah. So I would say that it's not, although yes you could, you're not getting closer to a simplified expression. Does that answer your question? Yeah, cool. I love those questions, I really do. Every time we ask a question about something which is not quite different from what we're looking at, it really helps deepen understanding, I reckon. The last thing I wanted to look at then, if I can move on, is where is root 2 on the number line? And I think I'll just unpack this for you because I don't want to spend the whole lesson doing it. And that is, for this particular part here, one of the last things we did is we said, well, how do we estimate where a surd might be on the number line, or the value of the surd? And this is just a simple one. But we would take something like root 2, and we would say, well, root 2, because, how do I put this? I'll get rid of the root sign. What's the 2 is a number. What's the first value below 2 that is a square number? 1. What is the first value above 2 that is a square number? 4, right? Because 3 is not a square number. So this is true, isn't it? This kind of means that 2 is sandwiched between 1 and 4. Now I'll explain why we're doing that in a second, but am I right so far? So 2 is bigger than 1, 2 is less than 4. That's what that notation means. You okay with that? Well, it's not much of a jump to say that therefore the square root of 1 is less than the square root of 2 is less than the square root of 4. Okay? And we know what the square root of 1 is, I hope. What's the square root of 1? And that's less than the root 2, which we don't know the value of without a calculator, and even then it's just an approximation. And then on the other side, Will, what's the square root of 4? Yep. So we can see from this that root 2 is between 1 and 2. So if I drew a number line and said, where is root 2? You could say, oh, it's somewhere between 1 and 2. Somewhere. I mean, you'd probably think it's probably closer to 2 than 1. It's actually, oh, it's not actually, it's 1.4 actually. So it's actually between 1 and 1.5. But you don't need to know that so much, just know that it's between 1 and 2. And I'll be really clear now, if you have a look at the, no, you can't look at the test, but the test will have that kind of question on it. It'll say place root 2 on the number line. It might not be root 2, but place this on the number line. And so you'll need to do that. Okay, all good? This is the time to ask questions. Okay, so what happens? What about this then? Does this kind of make sense to you? If I go 1 on root 2, so I'm trying to work out if the root 2 is on the bottom. Would that be 1 on root 1 and 1 on root 4 like that? Is that true?
No.
Kind of feels like it might be. Does it? Why not? Hannah, you're shaking your head very emphatically.
I know, I quite like my ponytail today. Because, yeah, well, the things are the wrong way around. Because the 1 over 4 is smaller than 1 over 1.
So if we go 1 over, we should shift it over?
Yeah, because then the root will be, yeah, well, I can't explain it, but yeah, like that.
And that kind of makes sense that if we evaluate the left-hand side, we would get 1. And on the other side, we would get a half. So we can see that we've already got it around the wrong way, haven't we? Because we've always got the smaller number on the left. So if I switch them around again, we'd say it's between a half and 1 on root 2 and 1. So 1 on root 2 would be between a half and 1.
Yeah.
Okay, want to do that on your calculator to make sure that's correct? It would be helpful for you to remember how to use your calculator to do stuff. Yeah? Have we got that? 1 on root 2 is about 0.7. If you can't use your calculator, you're going to be stuffed as well, so make sure you can. 0.707, something like that. Okay, so that makes sense as well, which is good. However, it required a little bit more brain work as well in order to get to that point. The other thing I wanted to point out is using this idea of a square root in the denominator kind of doesn't make sense either from our understanding of how fractions work. What does a fraction mean? A fraction means the numerator in the fraction, no, I'll do it reverse. When you have a fraction, the denominator represents how many parts I've broken something into, doesn't it? So I don't like to use pizza because that sort of implies that we always talk about breaking a whole number into it. But if I had a packet of Tim Tams, and let's just say it was an unusual packet of Tim Tams and it had 12 Tim Tams in the packet. If I ate a third of that packet, it means I've broken my packet of Tim Tams into 3 groups. So 1/3 of the packet of Tim Tams would be one of those groups, and so that would be 4 Tim Tams. If I ate 2/3 of those Tim Tams, that'd be like saying I'm selecting 2 of those 3 groups, which would make it 8 Tim Tams, because there's 4 in each group. Okay, this is primary school, grade 7 fraction understanding, but it's important to revisit. Everyone okay with that? Okay, so I've got a packet of 12 Tim Tams. I want to break it into root 2 groups. Doesn't make sense, right? Conceptually, breaking something into root 2 groups doesn't really make a lot of sense. So, for the reasons above, number 1, the conceptual understanding gets a bit tricky when we have a denominator. plus it doesn't really make sense to have square roots as a denominator, we do something called rationalising the denominator. And what rationalise, there's that word rational again. Rationalising a denominator means using equivalent fraction work to convert that bottom number, the denominator, from a square root number to, in our case, a whole number. Okay? I want to show you some examples. I'll just erase the methodology there. So I've got some examples that I want to work through so that you can understand how to go about doing it. You can see I've started off with a simple one here, 2 on root 2. And what we're going to do is we're going to use our fraction knowledge so that we can convert this into a fraction with a whole number denominator instead of a square root denominator. Then I've got a slightly more complicated denominator. Then I've got a slightly more complicated one again. Then I've got a complicated numerator here. And then I'll show you where we're headed. We're headed towards being able to do even more complicated denominators here. Now, some of you I know have done the worksheet with simple rationalising, but I don't know whether you've completed it. So I might need to put some more problems up on the board for you guys. But right now, I'm going to show you how to do the simple ones. 2 on root 2. Now, I'm going to zoom up just so we can focus on that to start with. 2 on root 2. We want to eliminate the root 2 from the bottom of our fraction. And we're going to use equivalent fractions in order to do so. Generally speaking, what does equivalent fractions mean?
They've got the same denominator.
No, they're not equivalent fractions. You can give me an example instead of telling me a general description if you like. Will?
They have the same value.
Yes, 2 fractions that have the same value are equivalent fractions. Perfect. Give me an example, somebody else. 1/2 and 2/4, or 3/6, or 9/18, or etc. All of these are equivalent of fractions. I can find an equivalent. If I start with 1/2, how do I make an equivalent fraction?
Multiply the top and the bottom by the same thing.
Thank you, Sam. Everyone get that? Multiply top and bottom. Okay, cool. You can multiply the top and the bottom or divide the top and bottom by the same number. What you're effectively doing is you're saying, if I multiply the bottom by a new number, that's breaking it into more parts. And then if I multiply the top by the same number, it means I'm taking more of those parts. So again, eating 1/2 a packet of Tim Tams is 6 Tim Tams in my 12-pack Tim Tams. Is 6 Tim Tams. It's 1 because each of the 2 groups has got 6 in it, so I'm selecting one of them. But if I've got 6/12, if I eat 6/12 of the packet of Tim Tams, I've broken the Tim Tams into groups of into 12 groups, which means there's 1 Tim Tam in each. But now I'm selecting 6 of them in order to eat 1/2 of the 6/12 of the packet of Tim Tams. In both instances, I've got 6 Tim Tams. Okay, so we want to rationalise the denominator. So what we're going to do is we're going to multiply the bottom of the fraction by the number that will get rid of the square root sign. What number will get rid of the square root sign on the bottom?
Root 2.
Awesome, guys. That was a few of you saying that. Root 2 times root 2 is just 2. But equivalent fraction says, if I multiply the bottom by root 2, what do I have to do to the top?
Multiply root 2.
Great. Good to hear some conversation there. So we multiply the bottom by root 2, we multiply the top by root 2, and so we've got on the top 2 root 2, and the bottom, we've just got 2. We've now rationalised the denominator, because now we've got 2 on the bottom, a rational number, instead of a square root. We okay with that? This problem's not finished yet. Why not?
But you can take out, you can divide the whole thing to root 2.
Yeah, there's a common denominator. Sorry, there's a common factor on the top and the bottom, isn't there? 2 goes into itself once, and 2 goes into itself once. So on the top, I've got 1 root 2, which is root 2, and on the bottom, I've got over 1. And whenever we have a number over 1, we don't need to write the over 1 bit. Like 6 over 1 is just 6. 10 over 1 is just 10. And root 2 over 1 is just root 2. So weirdly, and again, if you've got your calculators, confirm this. 2 divided by root 2 will give you a value. And then just do square root 2. It'll give you the same value. So on your calculator, if you go 2 and then divided by and then square root 2 and press equals, you'll get a number. Remember that number, not the whole thing, just look at the first 3 decimal places, something like that. Then clear your calculator and then do square root 2. You'll find in both instances you get exactly the same number. Another way of doing it is if you go 2 over root 2 minus root 2 on your calculator, you will get 0. I do want to move on, so if you haven't quite got that, that's okay. Maybe I can just do it really quickly on my computer so you can sort of see it. 2 divided by the square root of 2 minus the square root of 2 is 0. There we go. So they're the same value because when we subtract them, we get 0. Okie doke. In terms of being able to put this on a number line, for example, it does make it a bit easier. Because if I said to you, where is 2 on root 2 on the number line, you now know it's between 1 and 2. Because it's the same value as we had back here. Yeah? Okay, so the rest is just teaching you by examples how to deal with how to rationalise the denominator. Then I'll get you to practice it for a bit. I'll zoom up on example 2 and then I'll zoom out for the other one. This one here, 3 over 2 root 2. What's your gut feeling? What should we multiply top and bottom by? I'll give you 50-50. Multiply it by 2 root 2 or multiply it by root 2. Who reckons root 2? 1, 2, 3, 4, 5, 6, 7. Who reckons 2 root 2? Half a person does, who then put their hand up because the social stigma was too much for them. They couldn't bear being the only person here. Even though mathematics is not a democracy. But in this case, it doesn't work. It is correct that the majority was right. Just the root 2 is needed. Okay, because that's all you need to do to get rid of the root 2. So multiply the bottom by root 2, and therefore multiply the top by root 2, and that gets us 3 root 2 on the top. And you could do this in one step in your head, right? But I'll just do it for the notes. 2 times 2 on the bottom. You okay with that? 2 root 2, remember, means 2 times root 2, and root 2 times root 2 is 2. So we end up with 3 root 2 on 4. Or if you like, 3/4 of root 2. Hey, we'll shut the laptop, please. Okay, we all good with that so far? Awesome. So 3 root 2 over 4 and 3/4 of root 2. This second notation down here, you don't really need to know. I just think it's important to know that this is the relationship between this 3 root 2 on 4, what it really means. So again, 3/4 of root 2 is the answer. The reason why it's useful to know is if I got you to estimate it, then it is true that 3/4 of root 2 would be between 1 times 3/4, so it would be between 3/4 and 2 times 3/4, which would be 1.5. 2 times 3/4 is 1.5, right? So you can actually do that. You could say 3/4 of 1 is less than 3/4 of root 2 is less than 3/4 of 2. So it's really handy being able to rationalise so that you can estimate your surds. All right, let's have a look at example 3. I'll keep it all zoomed out so you can see them all. Root 5 over root 18. Okay, step 1. What are we going to do?
Simplify root 18.
We've got 2 choices there. Sam said both of them. Well done, Sam. Sam said multiply by root 18, but he also said simplify root 18. And that's when he corrected himself, and his correction is right. Although it would work by multiplying top and bottom by root 18, you're dealing with nasty numbers here. But look what happens when we simplify first. We would get root 5 on the top, and we've done root 18 on the board already, right? So I'm not going to muck around that too much. Root 18 is 9 times 3, so it's root 9 times root 3, sorry. So it would be 3 root 3. Now that 2 root 3.
No, 3 root 3.
No, 3 root 3, yeah. Now that we have rationalised, 3 root 2, sorry. Root 18 is root 9 times root 2, which is 3 root 2. Now that we've simplified the bottom, it's a lot easier to do the multiplication. What are we going to multiply top and bottom by?
Root 2.
Great to see multiple voices again. Here, multiple voices again. That's great. So on the top, what's the numerator going to be?
Root 10.
Right, they're 2 square roots, so we just multiply the numbers together and get our new square root, root 10. And on the bottom, we'll have 3 times 2, which is 6. So we've got root 10 over 6, or 1/6 of root 10. What do you think? Any questions on that? Example 4 is root 3 plus 1 over root 2. The fact that the numerator is more complicated means that we should slow down a bit, but the process is still the same. We look at the denominator, simplify it if we can. In this instance, we can't, so we've got to multiply the top and bottom by root 2. This will give me a next line, and I would do this next line if it were me, of root 2 multiplied by, in brackets, root 3 plus 1. So I've bracketed the numerator because I'm multiplying the whole of the numerator by root 2. And on the bottom, I've got root 2 times root 2, which is 2. Then I would expand it. So that means we multiply each thing inside the bracket by root 2. So root 3 times root 2 is root 6. Root 2 times 1 is root 2. Great. And that's all over 2. And now you're done. Yeah? So if you feel like you've mastered this, you could definitely go from, I would still put this down for communication to say, I understand what I'm doing, but you can certainly go from that line to that line if you felt like you could do that confidently without making mistakes. Okay, so what to do now? It is now 11:37, I'm just behind. What I want you to do for the rest of this lesson is, I'll just stop the video actually because no one needs to see this.